Greetings and welcome. My name is Aaron Craig with Let's Learn This Together. Pretty much in every game you're going to make, you'll need some sort of collision checking. That's what we're going to do today. So I can draw the collision box around the character that we have, and then I have an invisible object inside of this room that is keeping us from running into things that we shouldn't, and I think it looks pretty good overall. So in this video we are going to cover the collision function place meeting, collision masks, and while loops. Let's go ahead and jump right into it. You can download this starting project in the link down below. I'm just going to quickly go over what we have. If you want to skip, then you can jump to the next section. So this project has the object for the player, which is called obj peepo, and we've got a move speed, x speed, and y speed. These are speeds that we set, and then later on down the road we actually move. That looks like this. When we click on right, which are the inputs that we have right here, we click on it and we set our x speed to positive, left we set our x speed to negative, and then all the way down here, then we actually move our x and y. So right here is where we'll actually do collision checking, and I'll show you how we're going to do that. But that's what we've gotten here. This function, keyboard set map, just maps the VK keys to the WASD. That way I can move around with either. Inside of the room, I have some tile layers, which you can see I've used to create a nice little interior room. I have an asset, which is actually just this moving fire. The instance is just my object here. And then I have viewports enabled, which are this one camera of 320 by 240. And that's just so that I can increase the size of the window so you can see a little bit better. And then I have the camera following my player so that I can move around and explore the room. And that's all I have inside of here. So now let's get to actually creating some collisions. To do that, we're going to need an object. So let's go ahead and make a new one. I'm going to call this obj solid. And we're going to need a sprite for this. So I'm going to create a new one. And I'm just going to call this SPR solid. And I'm going to resize this to 32 by 32 because everything else in my game is 32 pixels. So this way it'll be the same size. I'm going to click on a red, double click on it here, change the alpha value, which is transparency. This will make it a lot easier to actually see the objects underneath our solid sprite here inside of the level. Then we go back to our object, and that's actually everything we need. We don't need to put any code inside of here because the player is going to control all of the code. So now what we have to do inside of the room is actually just put this object in here. So you have it selected and you can hold Alt or Option on a Mac and it'll just appear and you can put it wherever you want. Now, unless you go and change the origin of the sprite, if you have the grid on, it's going to appear in the middle, probably not where you want it. So whenever I'm doing collisions like this, I always turn off the grid so I can set it exactly where I want. I'm going to put it right there, and then I'm just going to drag it out to where I need it to be. And that's all you have to do. You just drag it around the edges of the room, and you put it on the objects you want. So on this table, I'll zoom in, and I'll just line this up, and then expand it, and there we go. I'm not going to cover up the legs because I want my player to be able to kind of walk up to the table. So you might even put it up a little bit higher. It all depends on the type of game you have and the style of your art. Since this is like a top-down 2.5D kind of game, I actually want to be able to walk up to the walls and stuff. So on these walls, I'm going to put the collision mask up a little higher. That way I can move up to them and kind of look at myself in the mirror if I want to, and so on and so forth. So this part is the most tedious because you're just laying down collision masks, but it's also pretty quick comparatively for other systems. Like, we don't need to have a different object for all of our collisions, just this one is going to work fine. And yeah, I think this works really well. A lot of people will say don't do this system because it's too complex or it takes too much processing power, but really it doesn't. This is a really great system in general. It is better for prototypes, and I wouldn't use it necessarily in a completely finished game unless it's kind of a smaller game. But at the same time, there's nothing wrong with this system that we're doing. This works and it works great. You're not going to notice an impact on your game while it's running because it's doing almost little processing. Like it's great. But there are more advanced and complex ways, which I will cover in another tutorial. And if you want to look at tile collisions, which is also really cool, you can check out my channel for some specific tutorials on that. But now that we have all of the objects inside of here, let's go into our player object and go to our step event. So our collision checking, what we need to do is use the function place meeting. Now, this is a function specifically for checking collisions. So let's go ahead and open this up and see what we've got. So this function is going to take our object, move it somewhere, and tell us if there was a collision with another object. It requires that both collisions or both objects have collision masks, and then they check the bounding boxes around those. Now, if that terminology is new to you, collision masks and bounding boxes, I'm going to cover that in just a little bit. The important thing to note here is that it returns a Boolean, which is true or false. That means we can use this function if we wrap it inside of an if statement. So if I say if place meeting, and then I tell it where I want it to check. So I'll say X, and the first thing we're going to do here is check for our horizontal collisions. So we're going to check our left and right. Now when we click right, we set our move speed to positive, and when we click left, our move speed goes negative. That means we can actually just add our X speed, because if we're going right, it'll check to the right, and if we're going left, it'll actually add a negative number, so it'll check it to the left just fine. So we check X plus X speed, Y, and obj solid. And you need 2 parentheses there. So I like to just put it like this, but you can also set it equal to true. That will work fine. But in an if statement, if something is true, you don't have to compare that thing to true, because this function is going to return true or false. So this is actually all you need inside of there. And if this is true, then we can set our X speed equal to 0. Now let me show you how this is actually working inside here. You can imagine our player, and this blue thing you can imagine is the collision mask. It's pretty close, but not exactly. But you can imagine this is the collision mask. So when we're right here, and we want to move 2 pixels over, the function is going to call place meeting, and it's going to move. We're going to click left and say we want to move 2 pixels, but before we actually do the movement, we're going to call place meeting and say, hey, is there a collision over here? I just moved the character 2 pixels to the left. If there is, then we're going to move back because we never actually moved. Remember, place meeting moves us, but we haven't actually moved our player until afterwards. So if we set our X speed equal to 0, then we never actually move. So if we're free, then we're actually going to do the move. And it does that every single time you want to move. So next time, here, we're still not colliding. But if we try to move left one more time, now we are colliding. So it's not going to allow us to actually move. And so now our collisions moving left and right should be working properly. So let's run into the table. And there we go. But when I try to move right, I can't actually move out of here anymore. If I move up, I can because we're not doing collision checking there. But we're actually seem to be getting stuck, and you can kind of see it, we're getting stuck inside of here. So a quick way to check this out, which I do all the time, is by adding a draw event to your object. We can draw our collision mask that we're doing. So the collision mask that we're currently using is inside of every sprite. So a collision mask is this right here. Every sprite has one, and any object with a sprite then also has that sprite's collision mask. And you can see that there are a couple modes and types. So we have automatic, full image, and manual. Manual lets you set it exactly the way you want, but for now we're going to leave it as automatic. And you can also see that down here there's left, top, right, and bottom. That's what's called the bounding box of where it's actually at on the sprite inside of the room. So right here, the bounding box, well, if we look closely, I put it right here. The bounding box for the left is 169 because you can see the values changing over here. So the bounding box changes depending on where the sprite is at inside of the room, which is important because that means we can go into the draw event And we can draw a rectangle and use those built-in properties, which we can access through bbox left, bbox top, bbox right, and bbox bottom. And we're going to draw this as an outline. Kind of sounds like I'm beatboxing there, but I am not. If we draw this rectangle, it's actually going to draw our bounding box, our collision mask, exactly as we have it, which is really, really cool. So if we come over here, we are not colliding with this, and we're right next to it, which is exactly what we want. And if I click right, so that's weird. Our collision mask has now changed, and we are colliding with it. So you can see that our collision mask is actually changing based on which way we're facing. And the reason for that is the collision mask changes based on the sprite you have. So if we come and look over at our left, you can see there's a bunch of blank space over here on the left. And on the right, there's a bunch of blank space over here on the right. So when we change directions, our collision mask is changing, and it's actually saying, hey, you're trying to move right, but there actually is a collision here because we're inside of it, so you can't move. So what we need to do is in the create event, we need to tell this object, hey, use one collision mask only. And we can do that by saying mask index equals, and then you can set it to any sprite you want. I'm going to set it to sprite index because that's the one we're using, and that's the one we're actually going to alter in just a little bit. But this will keep the mask index from changing every single time. And we're just going to have one collision mask. This is now going to allow us to actually move into here and then move out. You can see our collision mask doesn't change. And now our collisions for moving left and right are working as expected. Now, we can go in and actually alter our collision mask, which is really cool. If I click on manual, we can change this. And depending on the kind of game you want and the precision you want inside of it, you might want to, well, you're going to want to do it in a lot of different ways. For us, a top-down 2.5D game, I want our character to be able to walk up to this wall and not stop right here, because that looks really weird. I want them to stop right about here. That way they are clearly right next to the wall and they can like look into their reflection. So to do that, we're going to change the collision mask, and we're going to alter it. We're going to bring it down and over. We're going to bring this side over. So we are essentially only now on the bottom of our sprite. And this is still going to work for going left and right because we're checking basically where the feet is, because in a 2.5D game, we're standing up. We're not actually all the way over here, and that looks really good. Now, we don't have collisions going up and down, but you can see that this works as expected. Now, you might not want to be able to move up that far, so you can change the collision mask on the table, or you can change the collision mask on the character. That part's up to you. I'm going to make it, I guess, maybe a little taller, but I think that looks really good overall. Now, let's go back into the step event and do the vertical collisions, which are going to be almost exactly the same. If place meeting x, and this time we're going to check our y's. So y plus our y speed with obj solid, and y speed will get set to 0 this time if we have a collision. So with these two basic collisions, we now have collisions, which I'm saying a lot, are working inside of our project. So let's check this out. You can see here that we can now run into things. We can walk all the way up to the wall, and that looks really good. And it feels good too, so we can move right in between them as long as we're not actually colliding with them. So that's pretty much perfect. The only thing I want to show you left, which is still kind of important, is using a while loop to close any remaining gap between these. So we have a slight little gap between our collision mask and actually moving as close as we can to this. So if I get up really close, we can look at this pixel by pixel. So imagine that this blue box is our collision mask. If we are right here, if we're 1 frame away, so let's say we're 1 frame away, and we try to move into this table, our function right now is saying, hey, we're trying to move 2 pixels, but if we move 2 pixels, we are inside of it. So we are not going to allow you to move those last 2 pixels. Instead, we're going to stop you right here. Now, for 2 pixels, it's not a big deal. But what happens if we bump up the speed of our player? What if we change it to 5? Now, when we try to move into something and we're not quite close enough and it's not an exact mathematical match, well, now we're going to be a lot further away from it than we probably want to be, as you can see there. We're not getting nearly as close as we would expect. We are to some things, like moving up, like right here, that looks pretty much perfect. But right here, you can see that there's several pixels off. So what we can do about that is using a while loop inside of our collision. So a while loop, you say while, open up brackets, open up some curly brackets around the code you want to execute, and then while the thing inside of this is returning true, this code gets run continually over and over and over. Now it's giving me some errors because a while loop has to have an expression inside of it. So let's put one in. What we want to check is how close can we get? We want to get all the way right next to it. We want to get pixel perfect. We want to be 1 away from it. And then if we try to move 1 more and there is a collision, we're going to say, okay, this is where we will stop. And that while loop will allow us to get that close. So we're going to say while we are not, and you can use an exclamation point here to do the opposite of the expression. So while we are not place meeting x plus, and this time we don't want to do x speed because right now it's 5. And we don't want to be checking 5, we want to be checking 1. But if we say x plus 1, well, that's not going to work if we're moving left because positive goes to the right, negative goes to the left. So instead, we can actually use a function called sine and pass in the parameter x speed, or the argument x speed. And sine is a function that just returns 1, 0, or -1, depending on the value of what you pass in. So if our x speed is positive, it's going to return a 1. If our x speed is negative, it returns as -1. And if it's 0, it returns 0. That's all it does. But that's all we need it to do. Because then, if we are going right, this is going to be a 1. If we're going left, it's going to be a -1, which will work perfect. Then we'll say y and obj solid. So while we're not meeting there, x, we're going to move ourselves 1 pixel at a time, and the pixel we're going to move is that sine x speed again. And then let's come down here and do the same thing for y. So while, and this time I'll write this while loop a little different. I'll say while place meeting x, y plus the sine of y speed, obj solid, is equal to false. Sometimes that's easier to read, depends on what you're used to. I'm used to exclamation points meaning not and putting them in front of my things like I did right up here. But some people like to see this part, and there's nothing wrong with that. So both will work the same. Now we're going to say y plus equal the sine of y speed. And then you set the x and the y speed equal to 0 outside of the while loop. While loops, like for loops, all happen at once. So this entire thing, however many steps it takes, it's going to happen immediately. It's going to pause the game and run this. And so it's important to not have a super in-depth while or for loop because your game is actually going to pause and stall. Now, if it's small enough, you're not going to notice it like this. We're going to be able to get real close. We're not going to notice our game pausing or anything. And you can see we're getting exactly right next to where we want to be. Perfect. So that takes care of collision masks, while loops, and place meeting functions. This is the basics of collisions. You can download the finished project that you can see here if you want to test it out or copy the code into your own projects and just use that wherever you're at. This is the basics. You're going to also be able to find some more advanced collisions coming up soon on my channel, so stay tuned for that. If you enjoyed this and you want to see more content from me, then ring the subscribe button and hit the bell. You can also check out my upcoming book, So You Want to Be a Game Developer. That's going to be launching in the next month as the plan, and you can check out the links below for details on that. It'll take you from absolute beginner, doing stuff like this, to doing much more advanced stuff like this in the course of just 30 days. But that's what I've got for you today, so thank you very much for joining me, and as always, keep making, keep learning, and I'll talk to you later. A huge thank you to all of the awesome people who support me over on Patreon. Their names are on the screen now, and every dollar pledged helps me create more awesome content. You can support me for as little as $1 a month and get access to exclusive perks like my Discord server, your name in the credits, early access to my YouTube videos and courses, and more. Check it out at patreon.com/letslearnthistogether.com or find the link in the description below and become a patron today.